Hello viewer, my name is Chirag Pachori. I am a grad student in Energy Systems at University of Illinois Urbana-Champaign. And today I want to talk about something which did confuse me till my junior year in electrical engineering. And I see some of my peers working in solar panels and everything initially confused regarding this thing. So what is it? MPPT versus solar axial tracking. So before starting with this, I just want to clarify that I am making a few assumptions here that you have some working knowledge of electrical. You know what current is, you know what voltage is, you understand power and resistance, just a basic definition and everything. So let's get into it. What is maximum power point tracking? Oh, sorry. What is MPPT? MPPT is maximum power point tracking. So what I used to assume, and a lot of people did in my batch and everything. So what we thought was we have sunlight coming in from the sun. We have our solar panel. Some magic happens, and we get electricity. Right? So what I used to think MPPT is this. So we have sun going from east to west during the day, and I thought MPPT is something, a concept which is about tracking the sun. So as sun goes from east to west, the panel will move around, well, the z-axis uh, about this point for your screen, which is definitely not the case. This thing is not MPPT, it is axial tracking. So what is MPPT? Well, good question. Let's get into it. So well, not before, let's just get into it. Yeah. So this is um, IV curve of a solar cell. And if this thing doesn't make a lot of sense to you and you have never seen this black curve over here, so just think of it in this way. You have a solar cell, you have light coming on in it, and you put a voltage measuring device across this. You get some voltage and there is definitely some current. You measure those values and you plot the graph. That's it. So if you have voltage and current, you definitely have something which is power, which is voltage multiplied by current. So this is what the red curve is. It shows the power at different voltages. So clearly this is the point which has the maximum power, right? Now if we extend this point and this point, the maximum power point on the red curve leads us to this point on the black curve, which is the point of maximum power point current and VMPP. So these are the values of voltage and current at which we have the maximum power. So how do we handle this thing? How do we get to a point which has the maximum power? So if we plot a straight line from the origin to this point, the slope of this line gives us inverse of resistance. Well, if you know something about electrical and you have a working knowledge of electrical, then you know that dV upon di is basically resistance, right? So it's just that thing. So now you would think that if we need to vary the resistance to get to this point, so if you have a line like this, then you are not at the maximum power point. If you have a line like this, you are not at the maximum power point. If the inverse value of resistance is equal to this line slope, then you are at the maximum power point. So one would think that, well, you have something connected to your solar cell, and you are not going to change that load just to get the maximum power, because if you need to charge a battery, you need to charge a battery. You cannot replace that battery with something else, right? Good catch. So how do we get to the maximum power point using the load settings? Okay, so we have our solar cell, we have our load. We connect something between these two, which is our power electronic circuitry. And this lets us vary the overall value of resistance or that the solar cell has. What are these power electronic devices? This could be a like DC to DC converters. It could be buck converter, boost converter, or buck boost, or any other configuration. If this is not making a lot of sense to you, don't worry. It's just switching. So, and if you don't know anything about power electronics, just think of it like you put something, a black box between solar cell and load to get to this point. That's it. In a nutshell, maximum power point is setting the value of voltage and getting some value of current which gives you the maximum power. This is done by using electronic circuits for maximum power delivery. Solar axial tracking is actually tracking the direct sunlight. Now remember, we can only track the direct component of sunlight, right? I mean, you cannot track the indirect component of sunlight which is coming from clouds and atmosphere. It is more or less constant around the solar panels. And uh, if you don't understand this thing overall here, just get one point. This is not MPPT. That's it. Hope this helps. Thank you.